Hi, good day to the panel from IMDC 22 and everyone. In order to classify pineapples according to their size and weight, farmers usually measure each pineapple manually. It takes a lot of time and human resources to obtain pineapple information. From the cost point of view, it's not proportional and the work efficiency is very low. For the small owner who cannot afford to hire a lot of manpower, they need to spend more time and energy to complete the work. Therefore, this project can reduce the dependency on human resource for agriculture and improve work efficiency for farmers while saving time and energy, thereby increase farmers' income. Currently, there are a lot of solutions to detect the fruit size. So one of the system is light detection and ranging LiDAR sensor with visible and IR spectral sensor. It's a similar method based on image processing technique. The limitation is a very high cost, so the small owner is cannot affordable. For our solution is analyze the pineapple characteristic through the camera and image processing algorithm. The image processing algorithm will using the OpenCV and Python, and this software will be executed by the laptop and is low cost, and the farmer can set up this vision system easily. The target segment is farmers, farm manager, farm inspector. The impact to the target segment is reduce the dependence on human resources for agriculture, improve work efficiency for farmers while saving time and energy, thereby increase farmers' income. Next, vision system setup. This system is built up by a lightning device and a webcam. The lightning device is set up at the three sides of the sensing area. The fourth side or the last side of the sensing area is to facilitate place the pineapple. The webcam is set and fixed at the top of the sensing area. For the data execution, the first step is mark the angle in 0 degree, 120 degree, and 240 degree at the bottom of the pineapple, and it shows as the this figure, and the red line is the marking. The second step is place the pineapple at the sensing area and capture it in 5 different positions. The third step is measure and record the length, diameter, and weight of the pineapple. Fourth step is repeat the second step to third step in 120 and 240 degree, and repeat all the steps above with other pineapple. Next is the size and weight prediction. The size prediction of pineapple is using the pixel per metric ratio method. For the weight prediction of pineapple is using the linear regression method. The result of both prediction algorithm will be executed by the Python. First is detect the reference image to get the pixel per metric ratio. So the image we set, the image X is our reference image. So now we'll look at the image X. So this is the image X. So the real diameter is for the image X is 13.0 and the real length for the image X is the 15.2. So the step from line 19 until line 35 is the image processing algorithm to enhance the image so that we can get the contour. Now we run the code. So from here we can see that there is the bounding box here. So the width of the bounding box can use as the diameter of the pineapple, and the length of the bounding box is the length of the pineapple. So this is so from the line 41 until the line 111 is the method to use the bounding box to detect the contour and then get the length and the diameter. So for the DA is the height, which is the length of the bounding box, and the DB is the width of the bounding box. So by using these two values, we can get we divide with the real image, which is the 13.0 for the diameter, 15.2 for the length, so we can get the ratio of length and diameter. And these two value can be insert to the another code so that we can detect the others pineapple. After we get the ratio of the length and ratio of the diameter, we put these two values into the pineapple detection code. So the pineapple detection code and the reference code, the only difference is the last part, which is the compute the size of the pineapple. So the dA is divided with the real length for the reference, and the detection is dA divided with the ratio. So this equation can get the predicted value of length and also the diameter. So let's run the code. So the image we select is the image 68. So from the result, we can know that the predicted length is 10.6, and the predicted diameter is 10.06. So all the data I already key in into the Excel file. So for the second row and third row is for the manual measure diameter and length. For the fourth row and the fifth row is the result we get from the Python, which is the predicted diameter and predicted length. And the arrow is is the manual minus with the software divided by the manual and times 100%. So that this is the all the percentage error. So now we look at the image 68. So for the image 68, the diameter compared with the manual method and the software method, the error just 0.6%, and for the length is just 0.09. So that we can assume that this algorithm is very high accuracy. And the fifth row is the weight. So this software result and the weight will be moved to the third part, which is using the weight prediction. The third part is the weight prediction by using the linear regression. So we will read the data from the CSV file, which is the ML pineapple data.csv. So this CSV file is move the data from the predicted diameter and length and the weight to this CSV file. So the x1 will be the predicted diameter and x2 will be the predicted length and y will be the weight. So we run the code. So from this code, we can get the accuracy. The accuracy is the correlation coefficient. So when the correlation is moved toward to the 1, it means that the data will be more accurate. So since there is 94.56%, it means that the prediction is highly accurate. So for the result for formula for the linear regression, the intercept is negative 2033. For the variable length is the 179 and the diameter variable is 79. So this is the graph for the weight prediction. In conclusion, the idea to detect the size of intact pineapple and predict its weight is successful. By the result of the regression analysis, it has 94.56 accurate. It can assume that the prediction is reliable. With the changing trend of agricultural development closely centering on skill, precision, and facility, this project can strengthen the integration of agricultural machinery and agronomy and quickly realize labor mechanization for Malaysia agriculture. For farmers, the impact of this project can shorten working hours, reduce physical strength, and improve the work efficiency. Foremost, I would like to acknowledge the Almighty God for His benevolence and for granting me wisdom and perseverance, not only in the time of research and writing of this project report, but indeed throughout my life. I express with heartfelt appreciation my gratitude to my supervisor Dr. Chia Kim Sing for his sincere and innumerable intellectual guidance extended to me throughout the year of my postgraduate study. My sincere appreciation goes to the Ministry of Education Malaysia and University Tun Hosea Malaysia for providing me with the financial support. I extended my appreciation to all my friends for their unwavering support and who have understood me through so many tough times. Last but not least, special thanks to my beloved parents for their blessing and unflinching insistence, who have always encouraged me to never stop achieving my goal in life. That's all for my presentation. Thank you for watching.